Happy Sunday, everybody, and welcome to The Science Behind with me, your host, Harper Creffitz. This episode is the science behind the sixth mass extinction. Right now, as you're listening to this, species are disappearing, not over thousands of years, but today. Scientists believe we may be living through Earth's sixth mass extinction. The last time this happened, dinosaurs were wiped out. But is this really comparable to past extinctions, or is that an exaggeration? Let's get into it. First, what is a mass extinction? And if we're experiencing the sixth, then what about the first five? Slow down, I'm about to answer all of your questions. A mass extinction is classified as a rapid decrease in Earth's biodiversity, which just means the amount of different species, where a large part of those species die out within a very short time frame. Let's go through the first 5 mass extinctions of history, often called the Big Five. The first 2 mass extinctions were caused by rapid climate change, meaning the quick transition from heating and cooling of the oceans. The first 2 extinctions hit maritime life the hardest and wiped out 85% of marine species and 75% of total species. Both of these occurred around 400 million years ago and killed what was called the Age of Fishes. So now, let's get into the third extinction, also referred to as the Great Dying. The third extinction killed off more than any other one we've experienced, hence its title, killing off 90 to 96% of marine species and 70% of terrestrial vertebrae, which means land animals that have a spine and cranium. This extinction was caused by the massive volcanic eruptions in the Siberian traps, which caused intense global warming, the oceans became more acidic, and widespread oxygen depletion. The fourth extinction was also linked to massive volcanic activity and caused widespread environmental collapse. But for now, let's get into the most well-known one. Finally, the fifth mass extinction, the one we all know, the asteroid in modern Mexico that killed off all dinosaurs. Now, extinctions literally mean the death of life on the planet, but also have some upsides after the fact. When many species disappear, it opens up ecological space for existing species to expand and diversify. It also means less competition for food, space, and resources. After the fifth extinction, mammals were able to spread and evolve into new forms. Mass extinctions also lead to huge bursts of evolution, which is called adaptive radiation. New species evolve quickly to fill in those empty roles of the extinction and lead into huge changes in biodiversity over time. This is part of how we have animals like whales, primates, and eventually us humans. Extinctions also reset ecosystems, meaning they can rebuild even stronger and create new food webs, different dominant species, and encourage difference in species, like new body structures, survival skills, and interactions. So to sum it up, mass extinctions are catastrophic in the moment, but over millions of years they've reshaped life on Earth, opening the door for entirely new species, including us. So mass extinction isn't new, but what's happening now might be very different. To answer this question, are we in a mass extinction? We need to develop an understanding of what scientists mean by normal and develop a baseline. In nature, extinction is normal. Species evolve, adapt, and sometimes fail to survive. This slow, natural process is known as the background extinction rate. It's been happening for hundreds of millions of years. Under normal conditions, species might disappear over thousands or even millions of years, and new ones gradually take their place. But today, scientists are observing something very different. Current extinction rates are estimated to be 100 to 1,000 times higher than the natural background rate. But what's even more alarming is how fast this is happening. Not over millions of years, but within decades. So the big question is why? Unlike past mass extinctions, there's no single catastrophic event. There's no asteroid heading toward Earth. Instead, what we're seeing is the combined impact of multiple human-driven changes, all happening at once. Let's break that down. The biggest driver of biodiversity loss today is habitat destruction. As human populations grow, we need more land for agriculture, housing, infrastructure, which means forests are cleared, wetlands are drained, and natural landscapes are transformed into cities and farmland. But for many species, habitat isn't just a place, it's everything. It provides food, shelter, breeding grounds, and protection. When that habitat disappears, species don't always have somewhere else to go. Some try to migrate, others can't move fast enough, and many simply don't survive. Imagine if your entire home and everything you needed to live was suddenly erased. That's the reality for countless species today. And then there's climate change. As global temperatures rise, ecosystems are shifting in ways that are difficult for species to keep up with. Some animals are moving toward cooler areas, higher altitudes, or closer to the poles. But not all species can migrate, and even those that can may struggle to find sustainable environments. Timing is also being disrupted. For example, plants may bloom earlier due to warmer temperatures, but pollinators like bees might not be active yet. This creates a mismatch. Species that depend on each other fall out of sync. Over time, these small disruptions can cascade into larger ecosystem failures. Pollution is another major factor, and it's incredibly widespread. It shows up in different forms, like plastic waste in oceans, chemicals in soil and water, air pollution affecting both humans and wildlife. One of the most concerning aspects of pollution is how invisible it can be. Tiny particles like microplastics are now found in oceans, animals, and even human bodies. Toxins can accumulate in food chains, meaning predators are at the top and often most affected. It's not always dramatic, but pollution is quietly reshaping ecosystems from the inside out. Finally, there's overexploitation, using natural resources faster than they can recover. This includes overfishing, hunting, lodging, and wildlife trade. For example, some fish populations have declined so dramatically that they can't reproduce fast enough to recover. And when one species is removed, it doesn't just disappear. It affects everything that's connected to it. Ecosystems are like networks. If you pull one piece out, the entire system can shift. What makes this moment in history so unique is that all of these factors are happening at the same time, and they're all connected to human activity. Which means, for the first time in Earth's history, a single species is driving global environmental change on a massive scale. And that raises the question, if we're causing it, can we also stop it? Now you'll have to wait a little longer to get the answer to that huge question. First, let's look into what does all of this actually look like in the real world. So let's move from the big picture to specific examples from case studies, because this isn't just a theory, it's already happening. Bees are responsible for pollinating a huge portion of the plants we rely on, including many fruits, vegetables, and nuts. Without pollination, these plants can't reproduce. In recent years, bee populations have been declining in many parts of the world, a phenomenon often referred to as colony collapse. The causes aren't simple. It's not just one issue, it's a combination. Pesticides that are affecting their nervous systems, habitat loss reducing the availability of flowers, and climate change altering when plants bloom. And what makes this especially concerning is the ripple effect. If bees disappear, it's not just about losing honey, it's about destabilizing the entire food system. This is one of the clearest examples of how biodiversity loss directly connects to human life. Amphibians, like frogs and salamanders, are often described as environmental indicators. Their skin is thin and permeable, meaning they absorb water and anything in it directly into their bodies. This makes them incredibly sensitive to changes in their environment. Right now, amphibians are among the most threatened groups of animals on Earth. A large percent of species are at risk of extinction due to pollution, habitat destruction, climate change, and a deadly fungal disease spreading globally. Because they react so quickly to environmental changes, their decline is often seen as an early warning sign. When amphibians start disappearing, it's like an alarm system going off in the natural world. And the concern is what affects them first. Many eventually affect other species too. Coral reefs are some of the most diverse ecosystems on the planet. They support thousands of marine species and provide food and protection for entire ocean communities. But they're also extremely sensitive. When ocean temperatures rise, coral experience stress and can undergo bleaching, losing the algae they depend on for energy. If the stress continues, the coral dies. At the same time, ocean acidification is changing the chemistry of the seawater, making it harder for corals to build their skeletons. The result is something scientists are increasingly worried about: large-scale reef collapse. Imagine entire underwater ecosystems full of color and life slowly fading into empty, lifeless structures. And when coral reefs disappear, it's not just one species that is affected, it's thousands. The answer to solving the mass extinction is not simple, but it's also not totally hopeless. Unlike past mass extinctions, this one isn't being caused by something beyond our control. There's no asteroid and no unstoppable disaster. This time, the cause is human activity, which also means the outcome is still, at least partly, in our hands. One of the most effective ways to slow biodiversity loss is also one of the most straightforward: protect the places where species live. Around the world, conservation efforts are focused on creating protection areas like national parks, restoring damaged ecosystems, and replanting forests or rebuilding wetlands. When habitats are protected, species have a chance to recover, and we've already seen this work. In some regions, animals that were once on the brink of extinction have started to come back, simply because their environments were given time and space to heal. Another major puzzle piece is how we use the planet's resources. Right now, many systems are based on taking more than ecosystems can replace. Efforts towards sustainability include more responsible fishing practices, reduced deforestation, and a shift towards renewable energy. These changes don't just help the environment, they also make systems more stable long term. The goal isn't to stop using resources, it's to use them in a way that doesn't destroy the systems we depend on. Because climate change is such a major driver of extinction, addressing it is key. This includes reducing greenhouse gas emissions, transitioning to cleaner energy sources, and protecting carbon-storing ecosystems like forests and oceans. The faster climate change is slowed, the more time species have to adapt. And in many cases, time is exactly what's needed. One of the most powerful tools we have is something that didn't exist during past extinctions: awareness. We understand what's happening. We can study it, measure it, and respond to it. Governments, scientists, and communities around the world are working on solutions, but change also depends on collective action. The choices people make, what they buy, how they vote, what they support, can influence systems on a global scale. Mass extinctions in the past were turning points in Earth's history. They reshaped life completely. But this moment is different. This could be the first mass extinction where the species causing it has the ability to recognize what's happening and choose a different path. That doesn't mean reversing everything overnight, but it does mean slowing the damage, protecting what's left, and allowing ecosystems to recover where possible. So can we stop a mass extinction? Maybe not entirely. Some damage has already been done, but we can definitely put in the work to start helping. That's all for this week's episode. Thanks for listening to The Science Behind with me, Harper Creffitz. Please reach out to thesciencebehind.media@gmail.com or comment on this episode with any suggestions for future episodes or questions you may have. See you next Sunday, where we make science make sense.